Hi everyone, welcome back to Quantitative Reasoning. Today we are in section 8.3 and we're going to be looking at simple interest. There are really only two objectives for this section, and they are to learn how to calculate simple interest and to use the future value formula. So let's get to it. Okay, I know a lot of you already know what interest is, but some people may not, so let's just talk about what interest is. Interest is the dollar amount that we get paid for lending or investing money, or that we pay for borrowing money. So basically, interest is the price of using someone else's money. And if you let the bank use your money, then they pay you interest. But if you ask the bank to use their money, in other words, if you take out a loan, then they charge you interest. That's the price of using their money. The initial amount of money that we deposit or borrow is called the principal. The interest rate, which is given as a percent, varies from bank to bank, and it goes up and down depending on what the economy is doing. Now, there's more than one kind of interest, but what we call simple interest involves interest calculated only on the principal. In other words, with simple interest, you don't earn interest on interest. That's called compound interest, and we'll look at that in the next section. But in this section, we're only talking about simple interest, which only involves interest calculated on the principal itself. So here is the formula that we will use to calculate simple interest. It's just interest equals the principal times the rate times the time. When we write it down, I equals PRT. And there are a couple of things you need to know here. The interest rate, R, has to be expressed as a decimal. So you remember in the last section when we got ready to use percents in a calculation, we had to remove the percent symbol and move the decimal 2 places to the left. So that's what we mean when we say you'll have to express R as a decimal. So we'll still do that. And also you need to know that T must be expressed in years. So keep that in mind as we go through these problems. Sometimes they will give you the time in months, or you may even see the time given in weeks or days, but time has to be in years in order to plug it into this formula. So let's look at example 1 together here. It says you deposit $2,000 in a savings account at Hometown Bank, which has a rate of 1.2%. Find the interest at the end of the first year. Okay, so first we know that they are asking us to find the interest, find the amount of interest, and so we know we're going to need the interest formula. So let's write down I equals PRT, and then let's go back to the problem and pull out our known values. So first of all, the $2,000 that we deposit, that is the principal, the starting amount. And the rate is 1.2%, but we know that we can't use rate in its percent form in the formula, so we have to convert it to decimal form. So we remove the percent symbol and we move the decimal 2 places to the left. So that would make it go in front of the 1 and then 1 more place to the left. So it's going to be 0.012. Notice how the decimal is currently 2 places to the left of where it started. So that's our R. And then the time, they said find the interest at the end of the first year. So the money sits in the bank for 1 year, and so the time is 1 year. Always keep in mind that your time needs to be in years, and the reason for that is that the interest rate is the rate per year. So that's why time has to be in years, and if it's not in years, we have to convert to years. Okay, now plugging in our known values, PRT is going to be 2,000 times 0.012 times 1. And if you'll just multiply those together on your calculator, you'll get that interest equals $24. So what would happen here is you deposit your $2,000 in the bank. At the end of the first year, they owe you $24 on top of your $2,000 because you let them use your money for a year. So when you go to the bank to withdraw your money, they would actually let you withdraw $2,024. Okay, now here is part B, And it's very similar to part A, so if you would like to pause the video and try this one by yourself, that would be a good idea. And now I will go through it with you. So let's read together. You deposit $3,000 in an account at your town bank, which has a rate of 0.9%. Find the interest at the end of the first year. So again, it says find the interest. That lets us know that we're going to need our interest formula. I equals PRT. The $3,000 in the problem represents the principal, the starting amount, so P equals 3,000. The 0.9% is the rate, and so R equals 0.9%, but we have to remove the percent symbol, so move the decimal 2 places to the left. There would then be 2 zeros after the decimal but before the 9. So R equals 0.009. Always check that your decimal is 2 places to the left of where it started. Okay? And then time again is 1 year, and that's right here in the problem. Okay, so I equals PRT becomes I equals 3,000 times 0.009 times 1. And so the interest for this problem is $27. Now let's look at example 2 together. So it says a student took out a simple interest loan for $1,800 for 2 years at a rate of 8% to purchase a bicycle and a laptop. Find the interest on the loan. Okay, again, it says find the interest, so we know we're going to need our I equals PRT formula. The $1,800 represents the principal. The 8% represents the rate, and we need to remove the percent symbol from this and move the decimal 2 places to the left. Now remember, when you cannot see a decimal, it's at the end of the number. So if we move this 2 places to the left, it will go in front of the 8 and then 1 more place. So our interest rate in decimal form is 0.08. And then the time is 2 years. We're going to take out this loan for 2 years, and so T equals 2. Now plugging in our known values, PRT becomes 1,800 times 0.08 times 2. And so the interest is $288. So when this student pays back the money, they won't just pay back the $1,800. They'll have to pay that back plus the $288. That's the price of borrowing this amount of money for this length of time at this interest rate. And now let's try part B together. So you could try this one on your own if you would like to pause the video and do it by yourself. And now let's do it together. A student took out a simple interest loan for $5,800 for 4 years at a rate of 6.82%. What is the interest on the loan? Okay, so again, what is the interest? Tells us we need our interest formula. The $5,800 represents the principal. The rate is 6.82%. So when we write that down and we remove the percent symbol, the decimal is going to go 2 places to the left of where it currently is. So it's going to be 0.0682. And then the time is 4 years, so we will write T equals 4. Now plugging in our known values, PRT becomes 5,800 times 0.0682 times 4. And that gives us a total interest of $1,582.24. Now, I know that sometimes, let's go back and look at this rate again. Sometimes people might be tempted to round this off. Don't do that. Whatever they give you for the rate, keep all of those digits. And sometimes when you calculate interest, you're going to get extra decimal places. If you were to get more than 2 decimal places, you would round off to the nearest cent, because that's how our money system works. We don't need any decimal places past the second one to represent money, because a cent is the smallest coin. But you might be tempted to round this off to the nearest dollar. And again, if you're working in my lab, don't do it unless they tell you to round to the nearest dollar. Always read your instructions. There'll be instructions in blue under the answer box that will tell you either round to the nearest dollar or round to the nearest cent. So you don't have to guess what you're supposed to round to, but you do need to read those instructions. And so if they said round to the nearest cent, this would be our answer. And now let's look at part C together. And this will be the first one where they've given us the time in months instead of years. So it says, suppose you borrow $18,000 to purchase a car. If the interest rate is 7.5% and the loan is for 18 months, what is the interest on the loan? Okay, so we know that they're asking for interest, so we will use our interest formula. So I equals PRT. Then the 18,000 represents the principal. The 7.5% is the rate, and when we convert that to decimal form, it's going to be 0.075. And then the time is 18 months. Now be careful here. Do not plug in 18 for the time, because remember, time has to be in years. Now there are 12 months in a year. So to get this converted to years, we just need to divide by 12. So 18 months is 18/12ths of a year, and on your calculator, 18 divided by 12 is 1.5. Okay, now we're ready to plug our values into our formula. So PRT becomes 18,000 times 0.075 times 1.5, and then the interest amount is $2,025. Okay, let's go ahead and talk about future value. Now, the future value of a loan is just the original principal plus any interest that is due. So it says when a loan is repaid, the interest is added to the original principal to find the total amount due. So we could look at it this way. The total amount, A for amount, is the original principal plus the interest, and we know that the formula for interest is principal times rate times time. Okay, now if you remember from algebra how to factor out a GCF, that's what we're going to see in this formula. This formula right here is the same one that we have up here. It's just that on this second line, the P has been factored out. So instead of P plus PRT, it's P times 1 plus RT. You don't need to worry about how the factoring happened. If you don't know, then don't worry about it. But I will just point out to you that if you were to distribute P into this parentheses, P times 1 would be P, and P times RT would be PRT. So you can see that the two formulas are the same. It's just that with this one, you only have to enter the P into your calculator one time. So that's why this formula is a little more popular probably than this one, but they are both the same. And again, the A stands for amount due, and the amount is called the future value of the loan. And again, that represents the total that has to be paid back. And the P is the principal that's being borrowed, but that's also known as the loan's present value. So P for principal, P for present value, and then A for amount due, also called the future value. Okay, so here in example 3, we are going to be calculating future value. And it says a loan of $1,060 has been made at 6.5% for 3 months. Find the loan's future value. Now we know that the future value is represented in our formula by the variable A. So let's go ahead and write down our formula that contains the A, or the future value. So we know that A is the principal times 1 plus rate times time, 1 plus RT. Principal times 1 plus RT. Okay, now what was the principal? The principal is the original amount of the loan. So the principal is $1,060, and the rate is 6.5%. If we convert that to decimal form, that's 0.065. And then the time is 3 months. Now it's important to remember that it's months. So let's write down time is 3 months. To convert this to years, there are 12 months in a year, so 3 divided by 12 gives us the years. And 3 divided by 12 gives us 0.25, so we could think of this as 0.25 years. That means 0.25 is what we need to plug in for T. Okay, now over here, we're ready to plug in our values into our formula. So P is 1060, and then that's going to be times 1 plus R, which is 0.065, times T, which is 0.25, and then close that outer parentheses. So you see how these two inner parentheses, they're just really acting like a multiplication symbol. That's how we write it when we write it down. But now look how I'm going to enter this into the calculator. Okay, you can see the expression here the way we had it written down on our paper. But now when we enter this into the calculator, we really don't need to use all of these parentheses because this is just one number times another one. And we also don't need these leading zeros in front of the decimal. You can enter them, but you don't really have to. So when I actually enter it, it's going to look like this. I'm going to put 1060, and now because I want the 1060 multiplied by everything that comes afterward, I'm going to use that open parentheses, and then 1 plus the 0.065 times 0.25, and now I could press the close parentheses, but it's really not necessary. All I have to do at this point is press equal, and there's our final result. Okay, so here's our result from the calculator, and now notice that we have 3 decimal places here, but since we're dealing with money, we really can only keep 2 at the most. And remember, you're going to look for instructions that say either round to the nearest cent or round to the nearest dollar. If it said round to the nearest cent, you would want to keep 2 decimal places, so we would look at this 5 and we would say that's big enough that the 2 needs to go up to a 3. And that would give us a rounded value of $1,077.23. Okay, here's part B. A loan of $2,040 has been made at 7.5% for 4 months. Find the loan's future value. Okay, again, we are looking for A, which is the future value. And so let's go ahead and write down our future value formula. A equals P times 1 plus RT. The P is the principal, and in this case that is the $2,040. The R is 7.5%, or in decimal form that would be 0.075, and the time is the 4 months. Of course, we have to convert that to years, so we divide by 12, and 4 months is equal to 4 divided by 12 years. And now if you go on your calculator and do 4 divided by 12, you'll get a repeating decimal. So it's 0.333333. It's a third of a year. You know that 4/12 would simplify to 1/3. And so this repeating decimal represents 1/3. Now, if you look at it in decimal form, then you have to consider how many decimal places you're going to keep when you plug into your formula. And let me tell you that it's more than you would probably think. Now, in real life, if you're actually trying to figure out a ballpark amount of money and you don't need it exact to the very penny, you could probably just round to 2 decimal places or even 3 decimal places, and it would be fine. Like a difference of a penny or 2 is not going to make any difference in real life. But in my lab, of course, it will, because if you don't round to the nearest cent when they've asked you to, then they'll mark your problem wrong and you'll have to do it again, and it'll be a whole thing. So let me show you a way to enter this in your calculator where you won't have to decide how many decimal places to keep. And you can use what I'm about to show you all the time, or you can use it only when you have a repeating decimal to deal with. It doesn't matter, but let me just show you. So of course P, when we plug into our formula here, P is 2040, and then that's going to be multiplied by 1 plus R, which is 0.075. And then for T, instead of using the repeating decimal, I'm going to use the fraction. And you know that the fraction bar just represents division. So where I've got 0.075 and I want to multiply by T, I'm going to put times 4 divided by 12, just like that, and then close my parentheses. So here's what we've got written down in our notes, and I've got it written down the way it's going to go in the calculator here, but let's just see if we can read it off of the way we have it written, because that's what you'll have in front of you when you do your homework. So it's going to go 2040 open parentheses, 1 plus. Now we know that we don't have to enter this leading zero, and we know that instead of using all of these inner parentheses, it's just one number times another, so we'll just use the multiplication button. So 0.075 times 4 divided by 12. So 4 divided by 12. And then that's the end of the multiplication, and because it's the very last thing in our expression, we're ready to hit equal, so we don't even have to close that last parentheses, although you can if you want to, but you don't have to. So equals, and this time we got $2,091 exactly. Now before we go back to the notes, I just want to show you what would have happened if we had used 0.333 here instead of 4/12. So imagine we were using the decimal value for 4 divided by 12, and we rounded off to 3 decimal places. So then I would have 2040, open parentheses, 1 plus 0.075 times, this is where I'm going to use that rounded decimal value of 0.333. And look, it gets us close. It's only about 5 cents off. If you round this to the second decimal place, you would have $2,090.95. It's only a nickel off of what we got the other way, but that's enough for my lab to tell you that you're wrong and you have to do it again. So we don't want that. So that's why I'm recommending that whenever your years turn out to be a repeating decimal, instead of rounding off that decimal, just enter the fraction, just enter the division, and let the calculator do it for you exactly. And just to wrap up this example, we did get a future value of $2,091, and so of course that means that the 2040 plus the amount of interest that's paid on the loan would total to $2,091. Okay, here is part C. So it says a loan of $24,000 has been made at 8.5% for 6 years. Find the loan's future value. Why don't you pause the video and try this one on your own, and then we'll match up and see how it went. Okay, here we go. So we know that we are looking for A, which is the future value, and of course the formula is A equals P times 1 plus RT. All right, now the principal is the $24,000. The rate is 8.5%, or in decimal form 0.085, and the time is 6 years. So luckily for us, this time was given in years, so we will not need to make any adjustments in this case. The time was already given in years. Okay, plugging in our values, we'll plug in the 24,000 times 1 plus 0.085 times 6, and then close the parentheses. And I won't show the calculator for this one because I think we've already done it a couple of times, but you would get $36,240 exactly. So I hope that you got that value on your calculator. Make sure that you get it on your calculator so that you know you're entering it correctly. Okay, here is another future value example for us. This one says, in order to start a small business, a student takes out a simple interest loan for $4,000 for 9 months at a rate of 8.25%. How much interest will the student pay? Okay, so I want you to be aware of what the question is asking you, because that's how you will decide which of the two formulas to use. Remember, A stands for future value, so that's going to be the principal and interest put together. In this case, they're only asking for the interest, so when we get ready to plug into our formula, we want to make sure that we use the formula that calculates just interest, not the total amount. Okay, let's go to our problem and see what values we can pull out. We know that the $4,000 here is going to represent the principal, and we know that the rate is going to be the 8.25%, which in decimal form would be 0.0825. Okay, so that's going to be our R. And then we know that the time is 9 months. Of course, we have to have time in years, so we'll need to do 9 divided by 12 to get the years, and 9 divided by 12 is 0.75. And since that's not a repeating decimal, we feel comfortable plugging this into our formula. Okay, now we're ready for our formula. And so since they are asking for just interest, we need to use the I equals PRT formula. So that's the formula that calculates just the interest. And that's going to be the $4,000 times 0.0825 times 0.75 for an interest of $247.50. Okay, now in part B, it says find the future value of the loan. Now we do have that formula for future value, and we know that we could go ahead and pull that out, but we've already calculated the interest. We've already calculated PRT. So remember the first formula that we saw for future value? It said A equals P plus PRT. And in this case, I want to use this formula. And the reason is I've already done this work. I already know what PRT is. And P is just the principal. So the future value of the loan is just the $4,000 principal plus the $247.50 interest. So the future value of the loan is $4,247.50. And I'm really glad you got a chance to see this example, because now you can really see that the future value is just the principal plus the interest. But if you wanted to use the other formula, you certainly could. If you didn't already have this number, then maybe this formula would be more convenient, and you could plug in the numbers the same way we have on the last couple of examples, and you would still get the same answer. Okay, here is example 5, and this is another future value problem. It says, in addition to jeopardizing your health, cigarette smoking is a costly addiction. Consider, for example, a person with a pack-a-day cigarette habit who spends $7 per day, 7 days each week on cigarettes. How much will they spend on cigarettes in a year? Well, if they spend $7 a day and there are 7 days in a week, then they are going to spend $49 a week on cigarettes, and then there are 52 weeks in a year, so 49 times 52 gives us a total of $2,548 spent on cigarettes in a year. Now in part B it says if this person invested the yearly spending on cigarettes in a savings account with a rate of 1%, how much would be saved after 1 year? So in other words, they're asking us to find the future value of $2,548 after 1 year at an interest rate of 1%. So we know that if R is 1%, then when we plug it into our formula in decimal form, it's going to be 0.01. And let's go ahead and get our formula, and we'll plug in our values. The principal is the $2,548 that we're not spending on cigarettes, and then the rate is the 0.01. And since they said the time is 1 year, we'll plug in 1 for T. And now when you do that on your calculator, you will get a total of $2,573.48. So after 1 year at 1%, you won't earn a lot of interest, but you would earn a little bit. Let's keep going. Let's look at example 6. So part A says you borrow $2,500 from a friend and promise to pay back $2,655 in 6 months. What would be the simple interest rate that you would be paying? So in this example, we are kind of using our formula backwards. Every time we've used the formula so far, we have known the rate and we've been trying to calculate the interest, or maybe trying to calculate the future value of the loan. In this case, we know the principal. We know that we're starting out borrowing $2,500, and we know that the future value of the loan is $2,655, and we know that the time is 6 months. But what we don't know in this case is R. So we are looking for R. Let's go ahead and write down that the principal is $2,500, and the future value is $2,655, and the time is 6 months. Now, when we divide by 12, we'll get 6/12 of a year, or in other words, 0.5 years. Okay, now we have all our variables, and now we have to decide what formula to use. So notice that we have the future value, the A, so we probably need to use a formula that includes A so that we can use this value. And we had two different variations of the future value formula. We had the A equals P plus PRT, and then we had the other one that we've been using. And so I'm going to solve this problem two ways. I would like for you to see both, and then you can decide which one you like best, but I would like for you to see the difference between them so that you can choose. So I'm going to start with the same formula that we've been using. So this is the A equals P times parentheses 1 plus RT. Let's plug in our known values. So we know that A is future value, and that's 2,655. We know that P is the present value or the principal, and that's 2,500. And then 1 plus RT, we know we're looking for R, so that's going to stay R, but T is 0.5. So we're going to have parentheses 1 plus R times 0.5, close the parentheses. Okay, now to solve this, we're going to have to isolate the R, and that means we're going to have to eliminate these parentheses. So first, let's divide both sides by this coefficient so that we won't need these parentheses anymore. So I'm going to divide both sides by 2,500. On the left side, 2655 divided by 2,500 gives us 1.062. On the right side, the 2,500s cancel out, and it leaves us with 1 plus R times 0.5. Okay, now I'm still trying to isolate the R. So the first thing I've got to do is eliminate this 1. So I'll subtract 1 from both sides, and that will leave us with 0.062 equals R times 0.5. I'm going to write 0.5 times R. And then we will need to eliminate this coefficient, so we will divide both sides by 0.5. And the 0.5's cancel, and the 0.5's divide out from the right side, and that leaves the left side as 0.062 divided by 0.5, so R equals 0.124. Now, of course, we have to translate this into percent, so we move the decimal 2 places to the right and attach our percent symbol, and we will come out with R equals 12.4%. Okay, that's super, that looks great, but let's look at it a different way, and to me this is a simpler way. So I would like to start with that other variation of the formula, the A equals P plus PRT. And let's go ahead and substitute our known values in here. So the future value of the loan is the 2,655, the principal is the 2,500, and then PRT is going to be the 2,500 times R, which is what we're looking for, times the time, which is 0.5. Remember, the time in the problem that was given was 6 months, but we said if we convert that to years, 6 divided by 12 would be 0.5 years. Okay, now what we want to do is isolate R. So watch how I do this. First, I'm going to eliminate this 2,500, this extra term over here on the right. We will subtract 2,500 from both sides, and that will leave us $155 on the left side, but now on the right side, this term will add up to 0, so that will disappear, and we will have 2,500 times R times 0.5. Now what I've done is I've gone ahead and multiplied together the 2,500 and the 0.5 so I can have one coefficient in front of my R. And 2,500 times 0.5 is 1,250. So this 2,500 times R times 0.5 becomes 1,250 times R. And now let's divide both sides by 1,250 to isolate the R. So the coefficient cancels out from the right side, and that would just leave R on that side. And then for the other side, 155 divided by 1,250 is 0.124. And we know that when we convert that to percent, it will be 12.4%, just like we got doing it the other way. Okay, now I like this way better, and you might like the other way better. You can do it whichever way you want. But now let's go ahead and look at part B. And if you want to pause the video and try to do this one on your own, I think that's a great idea. And now if you've had a chance to do that, I'm going to work it with you, but I'm going to do it the simpler way, the second way that I showed you how to do it in part A. So let's read the problem together. It says you borrow $5,000 from a friend. You promise to pay back $6,800 in 2 years. What simple interest rate will you pay? And I'm going to start with that first variation of the future value formula. So I've got A equals P plus PRT. Now substituting in the future value of the loan, that would be the $6,800, and the principal, the present value would be the $5,000, and then PRT would be 5,000 times R times 2, because the time is 2 years. Okay, now let's go ahead and in one step, let's eliminate this 5,000. So I'll subtract $5,000 from both sides. On the left side, 6,800 minus 5,000 is 1,800. On the right side, the 5,000 minus 5,000 disappears, and all we have left is this term. But I'm going to combine these two factors into one coefficient. So 5,000 times 2 is 10,000, and then I've got this R here. Okay, now I want to isolate the R, so I'll divide both sides by 10,000. And on the right side, the 10,000s cancel out, and it just leaves R. On the other side, 1,800 divided by 10,000 gives us 0.18, and we know that when we convert that to percent, we'll move the decimal to the right 2 places and stick the percent symbol on there, and it will be 18%. And let's look at example 7 together. So part A says, you plan to save $3,600 for a trip to Europe in 2 years. You decide to purchase a certificate of deposit, also called a CD, from your bank that pays a simple interest rate of 2.5%. How much must you put in this CD now in order to have the $3,600 in 2 years? Okay, so in this case, we know how much money we want to finish with, and we're trying to figure out how much money we have to start with. How much do we have to initially deposit in the CD in order to finish with this amount of money? So basically, the fact that we're looking for how much we have to put in now, that tells us that we are looking for P, the present value of the loan, or the principal amount. Okay, what else do we know? From the problem, we know that R is 2.5%, and when we put this in decimal form, it will be 0.025. We also know that the future value of the loan needs to be $3,600, and we know that the time that we're going to have the money in the account is 2 years, because it says how much do we have to have now in order to have this amount in 2 years. Okay, so we have all these values. So in this case, because we're looking for P, and these are the values that we have, we will need to use the future value formula. So let's write down our future value formula. A equals P times 1 plus RT. And let's plug in the values that we know. The future value A is 3,600. The principal P is what we're looking for. And in parentheses, 1 plus RT is going to be 1 plus 0.025 times 2, because R is 0.025 and T is 2. Now notice that what we have here on the right side is P times everything in parentheses, and there are no variables in here, so this is just a number. Now what we could do is divide both sides by this whole expression, but I think it will be easier for you if we go ahead and evaluate this so that it's just one number. So on your calculator, I want you to do 1 plus 0.025 times 2, and you'll see that you get 1.05. So we're going to rewrite this as 3,600 equals 1.05 times P. So you see that 1.05 took the place of all of this that P is being multiplied by. And now to isolate the p, all we have to do is divide by 1.05 on both sides. And of course, the coefficient cancels from that side and leaves us with p equals 3,600 divided by 1.05, which is this big long number here. It's 3,428 point all of these decimal places. And of course, we will round off to the second decimal place because this is money that we're dealing with. But now I need to tell you something about calculating present value. See, this is the amount of money that we would need to invest exactly to get this exact result. If we round like we normally do to the nearest cent, then we would invest $3,428.57, and we would be lacking this small amount here, which would cause us to lack something here. So if this is your absolute minimum amount that you want to end up with, then you need to invest this much or more. So for that reason, whenever we're calculating present value, we always round up. Even if the next digit is not big enough to cause us to round up, we always round up on present value. So if we're rounding this to the nearest cent, because we have more decimal places after that second one, we will round here to $3,428.58. Or if they had asked us to round to the nearest dollar, it would have been $3,429. So just be aware of that when you're calculating present value. You want to make sure and round up, even if the next value does not tell you that you need to round up. And now let's cut over to the calculator real fast because I want to make sure everybody knows the easiest way to get this answer to show up on your screen. Okay, so here's our expression that we had, and we said that the first thing we were going to do is evaluate this expression in the parentheses right here. So on your calculator, you went 1 plus 0.025 times 2 equals, and so we see that this whole thing is equal to 1.05. And so you write it down so that it looks like that, and the next thing you want to do is divide both sides of your equation by 1.05. Okay, so when you've done that, you can see that you need to do 3,600 divided by this number on your calculator. You've already got the 1.05 on your screen. So I don't want you to have to type this number in again. Like, it's not that big of a deal for this one because it's just a little number. But what if it were a lot more complicated number? You know, sometimes you want to use the number that's showing on the screen, but later in the calculation, and you don't want to have to type that number back in again. So the calculator has this function called the answer function, and you can see it down here. It is the second function of your negative key. And so to use it, we have to press the second button. So to access any of these functions that are written above the button, you use the second key. So with the 1.05 on the screen, you'll go ahead and punch in 3,600 divided by, now I want to make the calculator recall that last answer that it had, so I go second answer, and it will remember the 1.05 and divide by it, and so that's our final answer right there. Okay, now here's one for you to practice with. So this is part B of example 7. And it says, how much should you put in an investment paying a simple interest rate of 3% if you need $4,000 in 6 months? So this is very similar to part A. If you'd like to pause the video and try it on your own, go ahead and do that. And now I will go through it with you. So of course we need the future value of the investment to be $4,000. So A equals 4,000. And then R is 3%, and in decimal form, of course, that is 0.03. And the time is 6 months. Now, we know we have to convert that to years, so 6 divided by 12 is 0.5 years. And we know that we are looking for the present value because we're looking for how much we have to start with. And let's get our future value formula. So here it is, A equals P times 1 plus RT. And we'll plug in our known values. So for the A, we'll put 4,000. The P will just stay a variable because that's what we're looking for. The R will be 0.03 and the T will be 0.5. So I'll have in parentheses 1 plus 0.03 times 0.5. And then the way we did it on part A was we went ahead and evaluated the number that we have right here. So let's go ahead and calculate 1 plus 0.03 times 0.5, and that will give us a coefficient for our P of 1.015. And then we want to divide both sides by 1.015, and that will cancel out from the right side, and we'll have P equals 4,000 divided by 1.015. Make sure and practice using your answer function on your calculator. And so that will give you P equals 3,940.8867. And so if we want to round off at a whole cent, then we would normally, look at the third decimal place and see if this needs to stay an 8 or change to a 9. But we remember that because we are finding present value, it doesn't matter if this is 5 or more or not. Even if this is less than 5, we are still going to round up because we're finding present value. So we never want to underestimate, and so we round up, and our present value that we need to invest would be $3,940.89. Okay, everybody, that's it for section 8.3. I hope you've learned a little bit about interest and picked up some things that you didn't know before, maybe learned something about your calculator. I will see you guys in the next section, which will be 8.4. Bye.